Welcome back, student, to part 3 of the topic lines and planes. In this video, we will talk about the distances. So we will focus a little bit about the distances. And the first one, we will do the distance between a point and a plane. So there is a formula to find the distance between a point and a plane. And this distance will be given by this formula here. Before I explain the formula, let's do a little bit. This is my point, B1, X1, Y1, Z1. And imagine we have a plane, which is here. This is the plane. And the point is outside the plane. So this plane is ax plus by plus cz plus d equal to 0, which is the most important piece of information. This is in the linear form. So the right hand side is exactly equal to 0. And we want to find this distance from here, this one. And this is, we will call it d. So we need to find this distance. And there is a way to find this distance using the component, and the formula will be as simple as this one. So the idea here is x1, y1, z1 will be the coordinate for the point. So it's kind of, I'm substituting the coordinate in the equation of the plane and take the absolute value to ensure that everything is positive. And down here, I'm dividing by the norm, the length, the magnitude of the normal vector, which is APC, the usual APC. Take the squares and take the square root. Whatever we get here will be the distance between the two, the point and the plane. Let's see a simple example here to see how this will work in example. So in example 14, we need to find the distance between the point -2, 2, 1 and the plane 3x minus 5y minus plus z equal to 5. Please pause this video, try to solve it by yourself, applying this formula here for the distance, and then play the video again and compare your answer. Okay, the first thing we notice here is that the equation of the plane is not in the linear form. So I need to rewrite it so that the right hand side is equal to 0. That's the most important piece of information. So I just take the 5 to the other side. Now, the formula for the distance, all what we need to do is we need to substitute, instead of x1, instead of x we write x1, instead of y we write y1, instead of z we write z1, and we write the same equation. So that would be just -2, 2, and 1. And down there, we have to divide by the square root of a square, b square, and c square. Square, b square, and z square, which is 1, -5, and 3. Remember, this is a, this is b, and the number here is c. Now, if you plug in this in your calculator, you should get 20 over square root of 35, which is approximately 3.38. So the distance between the point is of a distance 3.38 units from the plane that is given by this equation. That's the solution for example 14. So that's the formula to find the distance between a point and a plane. Next, we want to know what is the distance between two parallel planes. So you have two planes. They are parallel, they are not intersecting. There is the angle between them is 0 or 180. And I'm asking what is the distance from top to bottom, or for example, if they are in the top of each other. What is this distance? So here, if we draw something, so the first plane is given by this equation, which is ax plus by plus cz plus d1 equal to 0. And the second one is, of course, it should be parallel, so they will not intersect. And now imagine they are like kind of at top of each other. And this is the same equation because they are parallel. The ABC are multiple of each other, so I can assume they are the same. But this number d1 will be different, so d2 equal to 0. And then I'm interested to know what is the distance from here to here. And this is my d. Now, there is a formula to find the distance between two parallel planes, but from where we get the idea for this formula is we use the distance between a point in the first plane and the second. Now, if you want to verify or you want to see how we derive this formula, you need to find a point here, call it P1, as we did before, and find the distance between B1 and the plane. Now, what is this point? All what you need is to find this point and you substitute it here. So it will be x1, y1, z1, and then you substitute all this back to the second equation. And that's where we will get cancellation of the ax1 and so on. So we will get d2 up here. You can try it and see if you can verify or derive this formula up here. Now we will use it to find the distance between the two planes. We have two planes and we need to find the distance between them. Well, in this example, the first thing we notice is that the ABC is not the same. If you look at the formula before, we require the ABC to be the same in both planes. Now they are not the same. So let's see, can we make them the same? So the first equation, if we write it down, it will be equal to 4. And now here, I think there is a common factor, which is 2. So I can divide everything by 2. If we divide everything by 2, we get 2x negative 3y plus z, which is exactly what I want. And then I have 3 over 2. That's what we have here. Okay, next step is we bring everything back to the linear form. So it will be minus 4 equal to 0. And this one have the same ABC, except that d1 is not equal to d2. And now we apply the formula. What was the formula? The formula was d1 minus d2 over a squared, b squared, c squared, which is the same for both equations. So it will be negative 4, negative 3 over 2. This is d1 and d2. You can easily see them. And then square root of 2 squared, negative 3 squared, and 1 squared. Now, if we do everything correctly, this will be 5 over 2 square root of 14, which is approximately 0.67 units. So the distance between the two planes is 0.67 units from each other. And that's the idea. Of course, we can use this formula to find the distance between two secure lines. So I'll just write the idea here for the secure lines. So distance between two secure lines. Now imagine I have a line here, this is L1, and I have another line which is CQ to L1. Maybe something, they are not in the same plane. Somewhere else. They don't intersect, they are not parallel. So what is the idea? The idea is we find the planes P1 that contain L1. We find the plane P2 that contain L2. So we will get two planes, B1, B2. B1 will have the line L1, B2 will have the line B2. It will turn out that B1 and B2 are parallel. So we use the formula as before. That's it. So the idea just to find the plane that contain L1 and the plane that contain L2. So remember, to find the equation for the plane, you need a point on the plane, and that point you can get it from the equation of L1. And you need a normal vector to B1, which will be the same normal vector for B2. So how we will find this normal vector? We know the parallel vector V1 and we know the parallel vector V2 for L1 and L2. We have only to take the cross product between L1 and L2, and that will give me the normal vector for the plane. I will use it and I'll solve this equation. Thank you very much for watching.